this is week 11, day 21. Excuse me, it's Friday. Intro to networks. So what we did here, this is an IP address, right? And we use NAT, and we matched up with this one. This is the public. And over here, private. This is the work server 2. Let me see if I can highlight this a little better. Work server 2. So this is one of a public address, and it matches up NAT to this private address. This is a different server that matches up. So what we did here, if I can show this here, NIAC has this address, which means we can do whatever we want with those 8 bits. So what NIAC did, they borrowed 3 bits out of there. We're going to look at that more specifically. And they were able to make these networks. These are all public networks. Now, can you tell which one the academic IT has? Now look at this. We have 160 to 192. So we can use addresses 161 to 190. So here at the college, nobody else is using this group. So we can assign those internally to servers. Let's take a look. Here is our range that we can use in the academic IT area. Here's what the situation we have. Let me see if I can do this one. So we have these bits. We borrowed it right here. Maybe I can do this. We borrowed it right here. So we have 1, 2, 3, 4, 5. 2 to the 5th, which would be 32 minus 2. So we have 30 addresses we can use here, public addresses, for different servers and so forth. We borrowed 3 bits. That's how we got these networks over here. So in our scenario, we have a firewall which does NAT, and it converts to one of the addresses in our range. We can look at that more closely later. And this router, go to the internet, go to the main campus, when it sees the addresses that belong to the IT area, it sends them this way, right? And this is an example of a lab we have set up internally. Actually, this is pretty close to what we're doing currently. We have a router here that does NAT, converts our internal addresses to another private address, but on the network here. Then it gets NATed here to a public address. It allows us to do our simulation here. So if we look at that more specifically, right here's an example. Here's what I just went over. This part's the network, this part's for the host. Here's where we're doing NAT translations. We're actually taking this internal network, which whatever addresses we were using, and it converts it to a network that works over here. Actually 172.20.0/16. When it comes from here, gets NATed again at the firewall to a public address, one that's in this range, goes out to the internet. When it comes back, the multi-layered switch here for the college can determine which addresses should go this way, which ones go this way based on its routing table. And we talked a little bit about IP6, local length. IP6, we got 64 and 64 bits. That gives us 128. We have 48 here for the network, 16 for the subnet. And then we did a little example here. This is an IP6 lab we did. See IP6 addresses down here. Now this would be, let me look, this would be week 12. And we are on day should be day 22. Okay. Okay. Tech Talk AI Wednesday. Intro to networks. Okay, today we did some work, did that lab work I just showed on IP6. We did some more on subnetting, variable length subnet mask, start to transport layer. This is review. We have the TCP IP model over here. We have application, transport, internet, network access. Over here we have the OSI model. Right? Take data, we prepare the data at the presentation layer, encrypt it if we need to, set up a session, transport layer, break it into segments. We're worried about the order and the size and how we're going to transport the data. Reliable or unreliable. Those segments come down and we make a packet out of them. Here we're worried about path and IP addressing. We bring the packet down, encapsulate it some more, we make a frame if we're using Ethernet to MAC address, and then we physically put it on the medium. The internet is considered a packet switching network because when you're going to the internet, we go up to this layer, the network layer, check the destination IP, then we come back down. Move the packets up another router, back down, it's packet switching. Here we talked a little bit about subnetting. Here I said we need 6 hosts, 14, 14, and 6. So we need at least 14 hosts. We have 7 networks. I can count those for you. We use a different color. Here's 1 network, here's 2, here's 3, here's 4, 5, 6, 7. We're not counting the connection to the ISP. So that gives us 7 networks, and then the most hosts we need, we're right here. These two need 14. And then we start with this address. It's a /24. So this part we can't change, so we can subnet based on that 8 bits that are right there. Okay, so we started out, we need at least 14 hosts. So if we take 4 bits, 2 to the 4th is 16 minus 2, 1 for the network address, 1 for the broadcast address, and so that will leave us 14 hosts. Borrow here, then we have 1, 2, 3, 4 bits there, so 2 to the 4th, 16. We can make 16 networks out of that. And then I did the first one here. First one 0, second one is 16. That one right there, one group of 16. This address here. Then if we wanted to, it's a /28, right? 24. And we borrowed 4 bits, 25, 26, 27, 28. We could take that /28 with variable length subnet masking, and we could subnet it again. Alright, and that's it.